physical link, in most cases the bandwidth of these physical links is higher than the, for example, the other physical links to branches, because this is connected to the headquarter. In most cases, it is not possible now. It is not important now for us, but let me to say, for example, maybe this is a 10G or 10 gigabit per second links. But in branches, we are using, in most cases, the lower speed link. Also, as you can see now, we have point-to-point links between the R1, R2, R3, and R4. Okay, now, again, you know that we need to have connectivity between all sites with point-to-point links in this scenario. If you want to have point-to-point links between all sites, again, you should establish between the other sites this type of connection. For example, between the site 2, this is the site 2, let me to show you, okay, and here, let me to change the color. This is the connection of site 2, okay. First, for example, to the site 4, this is another point-to-point connection. All of them are E-line, okay. E-line is this type of connection. As you can see, when the number of sites are increasing, the using of the E-line is not so efficient. Look at here. This is the, for example, tag 3. With tag 3, we are sending the traffic to the, or tag 4. Okay, with tag 4, we can send traffic to the router 4 here. When you are using the tag 4, actually you are forwarding the traffic to the when the traffic receiving in the service provider should forward this traffic to the router 4, or it is not mandatory to using the tag 4. For example, you can use tag 4T, okay, and then this traffic can be sent from the service provider to the router 4. Also, we have another for example, E-line directly to the router 3. This is the E-line to the router 3. Here, assume that we can use the tag 30, okay? And the traffic can forward it directly to the router 3. Also, about the router 3, we will have another E-line. If you want, you can draw it. It's so easy. But you know that E-line is a good option, is a good practice, okay? When we have some little number of the sites and we want to connect that sites to each other. In most cases, when you are using E-line, you have, for example, 2 sites, 3 sites, a little more, a little less, okay? Not 10 sites, okay? When with 10 sites, you need many E-line. You know that we have, again, only one physical link. About the physical link, we don't need to increase the number of physical links, but about the logical connections that we should establish, we need more logical connection. And because of that, when the, for example, number of sites are increasing, the using of the E-line is not so easy and it is not so efficient. Also, you know that here we are establishing some virtual connection. The name of this virtual connection is EVC. Let me to write here. The name of this virtual connections are the EVC. EVC is the abbreviation of the Ethernet Virtual, okay, Circuits. Ethernet Virtual Circuit. This is the one EVC. And with EVCs, okay, we can establish the logical connection between our sites. Actually, about the physical topology, we are using only one link. But about the logical topology, we have multiple E-line. You know that when you are using the E-line, in each E-line, we are using different range of IP address. Look at here. In most cases, in the router 1, we should configure the sub interfaces. For example, fast Ethernet 002 for the site 2, fast Ethernet 003, and for the site 3, and then fast Ethernet 00, for example, 4. Okay, for fast Ethernet 002 means the link connected to the for example, the site 2, we are configuring encapsulation.funcq2, and after that, we need to assign one range of IP address. For example, here, I'm going to use 10.0.0/13. But between the, for example, router 2 and router 3, we should use the next range, 10.0.0/13. Between the router 1 and router 4, we are using 10 008/13. You know that here we have multiple, okay, multiple layer 2 connection, but not between all of these sources. Here actually we have multiple point-to-point, but virtual point-to-point Ethernet connections. Okay, look at here. This is same as that you have one physical link between router 1 and router 3, router 1 and router 2, router 4 and router 1. Okay, and also other routers with each other. Because of that, when you are using the E line, in each E line, okay, you need to use one subnet. Actually, we can say for each E line, we have one subnet. One E line, one subnet. Two E line, two subnets. Okay, it is so easy. We have a one-to-one relation between the, for example, E line and also the subnet. This is the first type of connection. In most cases, we are using the E line when we have the low number of the sites. Actually, the central site or the HQ LAN router uses a, for example, single 10 gigabit per second access link. The central site connects to, for example, 100 E lines, or maybe, for example, a little less, a little more, and all of the E lines sends and receive frame over the same access link. This is not actually access. This access is the name. Actually, this is a trunk link with different tags that we are receiving on this interface. Now let me to talk about the ELAN. What is the ELAN? ELAN means the multi-point Ethernet WAN service. What is the multi-point Ethernet WAN service? As you can see here, when you are using the, for example, point-to-point Ethernet WANs, actually you need multiple E-line. And when you have many sites and you want to connect all of these sites to each other, okay, it is not so efficient method that configuring, for example, multiple E-lines. It is better to using the ELAN services. In ELAN, as I mentioned before, exactly this is same as that we have one Ethernet switch between all of our sites. For example, here we can buy one ELAN service. In ELAN service, you are experiencing one switch between your sites. Actually, you can see that when you are buying the ELAN, okay, you have only one EVC, one multi-point EVC. You know that in the E-line, we are using multiple EVCs. Here you can see the EVCs. But when you are using the ELAN, actually, you don't have all of these EVCs. Let me to show you here. For example, now I'm going to show you what is happening when you are using the ELAN. ELAN is exactly same as one switch. Let me to show you here. We don't have all of these, for example, lines. And after this, and after that, this, and then here. Look at here. We have only one, for example, connection, again, physical connection with each sites to the service provider, to the POP, to the point of presence, okay? But now, in this, for example, in this link, we have one ELAN EVC. What does it mean? Look at here, you have one connection, one EVC, and this EVC connected to all of the sites. Okay, look at here, to the for example R1 from the to R2 and R3 and R4, and also another EVC. Let me to show you here. Maybe you can consider this is one EVC with multiple head. Okay, look at here. Assume that this is one EVC. This is not two EVC. Look at here. This is one EVC, and this EVC we have multiple head. That's it. If you want, you can create another logical topologies here, but in the basic form of the ELAN, actually we have only one switch here, exactly like this one switch that you have in the real in the one LAN. Okay, because of that here, for example, about the IP addressing, you should only assign one range of IP address. For example, 192.168.10/24 is the range that we are using here. The router 1's IP address is 192.168.11, the router 2's IP address is 192.168.12, and the router 3's IP address is 192.168.13, okay, and then 192.168.14 for the router 4. And when you are configuring the For example, routing protocols such as the OSPF, you will have neighborship between these 4 routers, and this means that when you are configuring, we are buying the ELAN, actually you don't need to configure multiple E lines between the sites. Only one EVC or